Bright Tuty. Every student matters.
Hello students, let's continue the chapter factorization. So the first topic that we are going to today is factorization using identities. So we have already done these three identities if you remember. A plus b whole square is a square plus 2ab plus b square. A minus b whole square is a square minus 2ab plus b square, and a plus b into a minus b is a square minus b square. So now we will use these identities. How will we apply these identities? How will we use these identities to get the factors and to do the factorization? Now this is what we are going to learn in today's session. So suppose you have this example, you have to express this as in form of factors. So we have x square plus 8x plus x. So x square can be written as square of x plus, is 16 a perfect square? Yes, it is a square of 4. Now here we can write 2 into x into 4, right? You just see it will give you x square, it will give you 8x, and it will give you 16. So it is actually a square plus 2ab plus b square. This is of the form a square plus 2ab plus b square, right? So this complete can be written as a plus b whole square. So what is a here? A is x. What is b here? That is 4. So it is a square of x plus 4. So the two factors are x plus 4 and x plus 4. This is the answer for this question. So you see how we have used these identities, applied this to the question, right? So whenever we will have to factorize things like this, we will see whether the first one and the last one, or we get the two of them as perfect squares and the third one is formed by 2ab. Clear? Now if you see this one, we have 4y square minus 12y plus 9. So 4y is a square of 2y, right? And square of 9, 9 is a square of 3. Okay, minus 2 into a is 2y, b is 3. So 2 2s are 4, 4 3s are 12y. Yes, we get the same thing that is written here. It is a square of a square minus 2ab plus b square, and this is equal to a minus b whole square, right? So this is of this form. So this can be written as 2y minus 3 whole square. So these are the two factors, 2y minus 3, 2y minus 3. So using the identity we have come to the factors, right? So two identities we have used. Let's try the third one also. 49p square, 49 is a square of 7, so we can write 7p square minus 6 square. So now it is of the form a square minus b square, that gives us a plus b into a minus b. So what is a here? 7p, and b is 6 here. So 7p plus 6, 7p minus 6. These are the two factors for this expression given. Clear? So see, we have used, I have made you understand three questions, right? The first one was on a square plus 2ab plus b square, the second on the negative one, and on the third one a square minus b squares. All the three identities are now explained how to apply to the questions. Now if you see this one, we have to factorize this. How will you factorize this? How to solve it, right? So you see here, this is a square minus 2ab plus b square. This is square of a minus b whole square and c square. Can we write that? Yes, a square minus 2ab plus b square. So if we just focus on these three, it is a square plus b square minus 2ab, that is a minus b whole square minus c square. Now if you see this and this are square of two terms, so this can be written as a square. So a square minus b square we can consider like them, or you can consider it as x square minus y square, that gives us x plus y into x minus y. So what is x here? A minus b plus c, right? This one, and then a minus b minus c. So these will be the two factors for this. Got it? So here two identities are used one after the other. First we use a square minus 2ab plus b square, and now we are using a square minus b square. Okay, now moving ahead, here is another identity. It is m to the power 4 minus 256. Right, m to the power 4 can be written as m square whole square minus 256 is a square of 16. So you see it is a square minus b square, that is a plus b into a minus b. So we know this can be written as a is m square, the term inside the bracket, plus b and m square minus 16. Now this cannot be further factorized. What about the second one that has a negative sign? Can we? Yes, definitely. M square minus 16 can be written as square of 4. So this forms a square minus b square again, and it can also be written as then a plus b and a minus b. So this is the factorized form of this given expression. Got it? So we have got these three factors and we have applied identities. The identity used here is a square minus b square in both the places. Two times we have used it, starting the first step and here in this step. Clear? Okay. Now you see here, now we will be doing factors of the form x plus a into x plus b. What does this mean? X plus a and x plus b. We are going to get the factors in this form. Okay, so we have x square plus 5x plus 6. How do we solve it? Just see, when we solve x plus a and x plus b, first multiply x with x plus b. X square plus bx plus, now multiply a with this bracket, so we'll get ax plus ab, right? So we get x square plus a plus b. In these two terms x is common, plus ab. So this is our ab. What is this? AB, and a plus b is our 5 here. If you compare, a plus b is 5, ab is 6. Is that clear? Now we have to think of two numbers a and b. Now see here, a plus b, sum we know, product we know. We have to think of two numbers whose product is 6 and whose addition or sum gives us 5. So for product 6 we have 1 and 6, right? But when we add them we get 7, we don't get 5, right? So let us think about 2 and 3. 2 into 3 will give us 6 and 2 plus 3 is 5 also. So we will now break this 5x, right? How we will break it? We'll write it as 2x plus 3x, okay? That is 5x only, and plus 6. Now you have to do the grouping. So from the first two terms x is common, okay, and you get x plus 2 here. When you take x common, you get x plus 2 inside the bracket. You take 3 common out of these two terms, you again get x plus 2. Of the complete, x plus 2 is common, so we are left here with x and here with 3. So we have these two factors for the given expression. Okay, so what I am trying to make you understand is we will get factors of the form x plus a and x plus b. We have a quadratic form given, okay, and using the formula that this will be AB and this is going to be A plus B, that is 5. So you have to think of two numbers. Okay, also you can try like this. 6 is there, 2 3s are 6, 3 1s are 3. So you have to try with 2 and 3. 2 and 3 is giving us 5. If this would have been something else, we would have tried other factors. Okay, moving ahead. So the thing that I have explained is generally here it is explained. Suppose the algebraic expression is of the form x square plus bx plus q. We find two factors a and b of q, right? Of q, that means two factors whose multiplication will be equal to q. So ab is equal to q and a plus b is equal to p, this one. Clear? So x square plus a plus bx plus ab. So when we solve it, just see, we solved it, multiplied x inside, okay, and we got x plus a and x plus b, which are the required factors. So whenever we will have this kind of equation, we will have the factors in the form x plus a and x plus b. That is the main thing that we want to explain here. Clear? And that is done here also. We got x plus a and x plus b. I got the equation from there. Okay, now here is the another question for you. You have to find the factors of this. So we have y square minus 7y plus 12. So if you compare it with x square plus a plus b x plus ab. So what is ab here? Ab is 12, okay, and this is 7 here, correct? So minus 7 is there. A plus b is minus 7. So a plus b is minus 7. So we have to think of the numbers whose sum is minus 7. Okay, so when you do the factorization for 12, prime factorization, you get 2 6 are 12, 2 3s are 6, 3 1s are 3. So see, 3 2s are 6, 6 2s are 12, we can do. 6 into 2 will give us 12. But when we solve them, right, 6 plus 2 is 8 or minus 8 if we do the negative sign, right? We don't get 7 from here. So we can try with 4 and 3. Yes, 4 and 3 will give us 12, and minus 4 and minus 3 if we take, that will give us 7 also. So we will write y square minus 3y minus 4y, because minus 3y minus 4y will give us minus 7y plus 12. So from the first two terms y is common, we get y minus 3. Minus here 4 is common, minus 4 is common, y minus 4 3s are 12, y minus 3. So y minus 3 is common in the complete, and y minus 4 will be left in the another bracket. So these are the two factors for this. What are the factors? Y minus 3 and y minus 4. Moving ahead, here is another question for you. So we need minus 12, okay, and the sum should be minus 4. So we need two numbers whose sum is minus 4 and their product is minus 12. Okay, so how can we write this? Just see, 6 2s is 12, we know. 6 and 2, yes, we can form 4 from here. So z square is equal to, z square minus. So we need minus 4z, so I'll take 6 of minus and plus 2z, because 6 2s are 12, I'll get minus 12, minus 6 into 2, and if I solve it, I'll get minus 4. Minus 12. So from these two and from these two terms, you need to take out common factors. So here z is the common factor, z minus 6 you will get, plus 2 is the common factor, z minus 6. So z minus 6 is common, and the another factor will be z plus 2. So these are the two factors of this. Okay, what are the two factors? Z minus 6 and z plus 2. Clear? So what we are doing here is we are applying a plus b as the sum and ab as the product, these terms. Okay, and then solving the questions. Moving ahead, we have one more question for you. 3m square plus 9m plus 6. So in the complete, is something common? Yes. Of the complete, 3 is common. M square plus 3 3s are 9 plus 3 2s are 6. Now we want the sum as 3 but the product as 2. So 2 into 1 gives us 3. 2 into 1 gives us 2, and 2 plus 1 gives us 3. So yes, this is perfectly suitable here. So we'll write m square plus 2m plus m plus 2. 2m plus m is 3m. So 3 is common. Out of these two, m is common. So what we will write here? M plus 2. Then 1 is common, m plus 2. Right, so we have 3. Now m plus 2 is common in the complete, and m plus 1 would be left. M plus 2 is taken out, m plus 1 is left here. So these are the two factors, m plus 2 and m plus 1, and 3 also.